Imagine waking up one day and realizing that your memories aren't just in your brain anymore. They could exist somewhere else, on a computer, ready to be replayed anytime. At first, it sounds like science fiction, but scientists are actually exploring ways to map and upload human memories. So the big question is, can we really upload our memories one day? And what would that mean for our mind, our identity, and even our future? In this videocast, we're going to break it down in a simple science-based way. Before starting, please subscribe to help the channel progress.
Imagine this for a second. It's a deeply unsettling scenario. One moment you're lying in your bed, and then the next you wake up.
Okay.
But you're not in your room.
Yeah.
You are inside this vast, sprawling network of just pure code and data. Your memories, your personality, your deepest self, it's all digitized. It's all alive inside a machine.
And that's not just, a sci-fi plot anymore. The concept of mind uploading, taking the entire contents of a human consciousness and transferring it into some kind of synthetic substrate, is actually being taken seriously.
By who?
By neuroscientists, by philosophers. It's a real field of inquiry.
And that is exactly our mission for this deep dive. We're going to try and cut through the hype to explore the actual scientific feasibility. I mean, could we realistically scan the 86 billion neurons in your skull?
And not just scan them, map the trillions of connections between them, and then simulate that result so precisely that a truly digital version of you actually exists. So we need to figure out what's theoretically possible versus what's, practically achievable. And that means grappling with the staggering scale of the human brain, the limits of our current tech, and, well, the profound ethical and philosophical chasm that just opens up the moment you ask the question.
Is that digital copy still me?
Exactly. We've pulled together the latest thinking on the science of memory, the technical hurdles, and those ultimate questions of identity to give you a real shortcut to understanding this revolutionary idea.
Okay, so let's start where the rubber meets the road. The biology of memory itself.
Yeah.
Because if we want to upload a brain, we have to kind of treat it like a digital storage device.
Right. But that's the problem. That comparison just falls apart almost instantly.
Why? Why is the human brain absolutely not a hard drive?
Because digital memory, like a file on your computer, it's fixed. It exists at a specific physical address until you deliberately move it or you delete it.
It's static.
It's static. Biological memory is. It's fluid. It's dynamic. It's constantly rewriting itself. It's a process we call synaptic plasticity.
Right. That's a constant remodeling of the brain's physical structure. We're not just talking about neurons. We're talking about the connections, the synapses. And those connections literally strengthen or weaken based on your experience. It's not storage. It's a living process.
A really good way to visualize this difference is to think about roads, not files.
Okay, roads. How so?
Well, if you use a road frequently, it gets wider, right? It gets clearer, faster to travel. That high traffic makes the physical connection stronger.
And if you stop using it?
If you stop using an old memory, that old road, it just deteriorates. It becomes overgrown, hard to access. The memory itself is defined by the strength or weakness of those physical connections.
So when a memory forms, it has to leave some kind of physical trace then. Is that correct?
Yes, absolutely. That physical trace is called an engram.
An engram.
It's the specific group of neurons that, when they're activated together, retrieve a particular memory. And forming an engram involves these profound biochemical and physical changes right there in the cellular structure. It is a literal change in your gray matter.
And what's so fascinating is how tangible this is becoming. I mean, there's that famous work using optogenetics.
Oh, yeah, with the light.
Right, a technique where scientists can genetically modify neurons so they respond to light. They were able to shine a light on a specific group of neurons in an animal and essentially turn a fear memory on and off at will.
Which is powerful evidence. It shows that memories really are encoded in specific physical neural hardware.
But there's a catch.
There is, and it's a critical twist. It's a huge problem for the whole concept of uploading. The moment you access or recall that enneagram, it becomes, just for a moment, unstable.
Wait, unstable. You're saying if I recall what I had for lunch yesterday, that memory changes?
Yes, just slightly. It's a process called memory reconsolidation. When you retrieve a memory, you sort of take it out of storage, and for a very short window, it's pliable. It's like clay.
And when you put it back?
When you put it back, you might have integrated new details or reinforced certain parts, or maybe smoothed over others without even realizing it.
So it's not like looking at a fixed photograph in an album. It's more like a painting that you retouch slightly every single time you look at it.
Exactly. And over a lifetime, that painting is going to look quite different from the original.
And that's the fundamental biological challenge, isn't it?
Yeah.
If we capture a scan of your brain at 10 o'clock in the morning, we're just capturing a single snapshot of this constantly drifting self-editing system.
What's the guarantee that that scan captures the essence of the memory and not just its current temporary configuration? It's a huge problem.
Yeah.
And that instability, it leads us right to the technical and the philosophical roadblocks. Because the sheer scale of mapping that constantly shifting landscape is just staggering.
We're talking 86 billion neurons. But it's the connection count that's truly mind-boggling. It's something like 1,000 trillion synapses.
A quadrillion, yeah.
So even if we had a perfect blueprint of every single one of those connections, is that even enough?
No, not even close. The simulation has to be what scientists call functionally equivalent. It's not just the structure, it's the function.
What does that mean exactly?
It means we'd have to account for the intracellular mechanisms, the exact molecular concentration of neurotransmitters, the real-time biochemical processes, all the things that define how a neuron fires and behaves. You're mapping a constantly running, chemically fueled supercomputer, not a piece of static hardware.
And if we look at what our current technology can do, things like brain-computer interfaces, BCIs, we really see the gap. BCIs are incredible. They're allowing paralyzed individuals to control limbs or communicate.
They are.
But how far away is that from full brain mapping?
Miles away. I mean, just light years away. Current BCIs are phenomenal at detecting broad intent. They can decode simple commands like the electrical spike tied to the thought, I want to move my hand, but they're very low bandwidth.
So it's not reading the thought itself.
Not at all. Think of it this way. We can read the general emotional tone or a simple command, but we can't decode the complex syntax, the grammar, the nuance of a thought like, I wonder if I should take that new job in Chicago given the cost of living.
So it's less about recording the sounds of the brain and more like recording the vibrations of a symphony orchestra. You know something massive is happening, but you can't isolate the individual notes or understand the composition.
That is a perfect analogy. To do true uploading, we would need technology that can scan at molecular resolution. It would have to capture the state of every synapse and every molecule at the exact same time, and we are nowhere near that today.
But let's do a thought experiment. Let's say we solve it. We build the perfect scanner, the perfect simulation. We create a digital copy that acts, thinks, and remembers exactly like the original human.
Okay.
This is where the core philosophical problem of consciousness just crashes the party, right?
It absolutely does.
No.
This is what people often call the hard problem. If you create a perfect digital twin, is that twin truly conscious, or is it just simulating consciousness perfectly?
Could that twin really be you? Or just an extraordinarily advanced clone?
And this gets to the question of what's called substrate dependence. Many would argue that consciousness isn't just about the information pattern, the organization of the neurons.
Right.
They'd say the actual experience of consciousness relies on the unique biological, the chemical, the molecular environment of our carbon-based brain.
Right.
If you move that pattern to silicon, are you losing the essence of subjective experience?
So the feeling of being alive.
The feeling of being alive. The biological brain is this integrated system information, chemistry, emotion. They're all inseparable. A simulation might reproduce the output, but without the original messy organic inputs. Some argue it would be an experiential void, a functional twin, but with nothing going on inside.
Okay, if we can just set aside the philosophical voids for a minute and look at the futurist promise here. This tech opens the door to digital immortality.
Right.
The idea that a simulated self could keep living, keep evolving, long after the biological body has decayed.
It's a really compelling vision, but it forces us to ask that uncomfortable question again. Are we creating a true continuation of the self? Or are we just creating an archival copy that inherits the belief that it's the original?
Let's make that more relatable. Let's go back to memory and context. If I upload my entire life story, My diary, my journals, all my memories. It's just archived data.
But a physical diary contains so much more than ink on a page, right? It carries the smell of the paper, the stains from spilled coffee, the texture of the page where you press down really hard, writing something emotional.
The sensory context.
Exactly. When you scan it, the digital version might reconstruct the words perfectly, but it loses that immediate sensory experience. If we scan your brain, the digital version might read the memory file, but does it feel the original rush of adrenaline or smell the rain that was there in that moment?
And that distinction between reading an archived copy and genuinely experiencing the original emotion, that's where our whole definition of self just breaks down. You have to ask, are we preserving data or are we preserving a being?
That said, it is really crucial not to let this far future goal of digital immortality overshadow the very real, tangible benefits that this research provides right now.
Oh, absolutely. The BCIs.
The BCIs are already revolutionizing medicine.
Even if full uploading is science fiction for centuries, the technology pushing these limits is yielding incredible medical breakthroughs today. It's helping people with severe paralysis communicate, regain motor control.
And the research into memory systems is directly aiding patients with brain injuries. It's addressing neurodegenerative diseases. We're also moving toward creating advanced external memory devices.
Like a brain flash drive.
Sort of, yeah. Tools that could record and assist your biological memory. These are life-changing technologies that serve a much broader purpose than just achieving immortality for, a wealthy few.
But whenever a technology promises to fundamentally redefine what it means to be human, the ethical shadows are right there behind it. What are the key risks we have to monitor?
Privacy is. It's paramount. If we can scan and simulate the brain, then memories become hackable. The extraction of your personal memories, your deepest fears, your financial passwords, your private relationships, it becomes the ultimate form of surveillance or fraud or coercion. Memories are the ultimate proprietary data, and we have zero legal framework to protect them.
And access is the huge concern. If this tech ever becomes viable, who gets to upload? Is it just an amenity for the ultra-wealthy, making the societal and biological divide even deeper?
Precisely. And then there's the complex legal fallout. I mean, if a simulated version of you commits a crime in the digital world, does the biological original share responsibility?
What rights does a digital life even have?
These aren't trivial questions. They determine the future of legal personhood. And finally, you have ethicists who raise a really important caution about research focus.
That we might get distracted.
Exactly. If all these resources are poured solely into the pursuit of transhumanist goals like digital immortality, does it divert attention and funding away from crucial, immediate research into treating existing diseases like Alzheimer's or Parkinson's? So, to bring this all back to the present moment, look, the biological framework of memory makes mind uploading theoretically complex. But most researchers would probably agree it might be possible someday.
But practically, we are incredibly far off. We lack the scanning technology, we don't fully understand the language of memory, and we haven't even begun to answer the philosophical question of whether a digital copy can truly experience consciousness.
Even if we overcome every single technical barrier, the creation of a digital double just fundamentally destabilizes what we mean by the self. The scientific debate forces a philosophical reckoning.
Which leaves you, the listener, with the ultimate question. If a perfect conscious digital copy of you are created, and only one of you could continue experiencing reality, which one is the original? And who deserves to continue?
This discussion, in the end, isn't just about fun futurism. It really guides how we decide to use our incredible scientific potential. The tension we face is whether we aim this power solely at archiving the self for immortality, or if we focus it on immediate human improvement, healing the brain, restoring function, and broadening access to cognitive repair. That decision is going to define what it truly means to be human in the age of advanced neurotechnology.
Uploading human memories isn't just a futuristic idea or a sci-fi dream. It involves our brains, our neurons, and technologies that are still in their early stages. If it becomes possible, it could change the way we live, learn, and even remember our past. So next time you think about your memories, remember, they might not stay just in your head forever. I'm really glad you joined me in this videocast. Before you go, don't forget to hit that subscribe button for more mind-blowing science explained simply.